Hi, I'm Amanda, and I'm going to talk about recovery planning for the Sihek or Guam kingfisher. The Sihek are endemic to the island of Guam. However, sadly, they were extirpated from Guam after the accidental introduction of predatory brown tree snakes to the island, and this resulted in the extinction of Sihek in the wild by 1988. However, luckily, before their extinction in the wild, 29 individuals were able to be caught and were transferred to breeding facilities to start a breeding programme. And currently, the captive population size now consists of about 135 individuals in breeding facilities across zoos in the US mainland, as well as in a breeding facility at the Department of Agriculture on Guam. And the ultimate aim of recovery of Sihek is to reintroduce Sihek back to Guam. So in this talk, I'm going to talk about the ex situ population viability, as well as planning strategies for releases of Sihek back to the wild. So if we first consider the viability of the ex situ population. So although 29 individuals were able to be caught from the wild, the ex situ population is actually founded from only 16 wild birds. And that's because not all 29 individuals successfully bred. And we know that small populations can be at risk from inbreeding, which is the breeding between related individuals. And this can lead to a reduction in reproductive success or survival, which is termed inbreeding depression. And we were pretty concerned about whether inbreeding depression was impacting the Sihek population. So we decided to investigate this using pedigree data available from the captive breeding programme. And we found that indeed individuals with higher inbreeding levels did have shorter lifespans and lower reproductive success than more outbred individuals. So we know that inbreeding depression is impacting the ex situ population, but does this translate to an effect on the population's viability? So we investigated this by building population models. And you can see some of the results of this on the graph here. So you can see the Sihek population size projected forward through time, and this blue line shows a scenario of current management. And you can see that under current management, the population is actually projected to decline into the future. And then this black dotted line shows a scenario of removing individuals from the captive population for releases back to the wild. And you can see that under this scenario, the rate of decline is actually increased. So that's quite concerning because it means if we did remove individuals from the ex situ population at the moment, we could potentially impact the population's viability. And if you're more interested in this work, this is open access and available at Scientific Reports. So what can we do about that? Because we do need to remove individuals from the captive population to recover the Sihek back to the wild. So we went to the population managers and we came up with a scenario of increasing breeding in the captive population. And that's this blue line here. And you can see that under this scenario, the population can increase in size. And this black dotted line is our same scenario of removing individuals for releases to the wild. And you can see that under increased breeding, the population can actually support those removals of individuals to the wild. And the population then increases in size after we carry out those releases. So that suggests that with increased breeding, the population can actually support releases. So we can recover the species back to the wild. However, if I draw your attention back to that blue line, the population size is constrained at about 200 individuals, and that reflects the limited space available in zoos. So that really highlights the urgent need to recover Sihek back to the wild as soon as possible so that we can grow the population size to greater than 200 individuals, because 200 individuals is really still a very small population size. So we know that the captive population can support removal of individuals for release to the wild if we can increase breeding. But where should we release the Sihek to and how should we go about those releases? So we've been carrying out stakeholder planning workshops to engage with all our stakeholder groups. So the groups who have a stake in recovery planning of Sihek, and we can then identify our different stakeholder objectives and also come up with alternative release strategies. And we can then balance those alternative release strategies across our identified objectives to come up with our final recovery strategy. And this means that our recovery strategy then encompasses both the values of our stakeholders as well as the science. So what potential release sites are we considering? If we first think about Guam, so this is our ultimate goal, is to recover Sihek back to Guam. However, currently brown tree snakes are still present on Guam, and this could impact the success of any releases there. So for our first releases, we're considering islands outside of Guam. So for example, release sites in the Northern Mariana Islands, in the Federal States of Micronesia, are also a bit further afield, Palmyra Atoll. So Palmyra Atoll is a wildlife refuge, which is co-owned by the Nature Conservancy as well as the US Fish and Wildlife Service. And this is potentially an ideal site for first trial releases, so is being considered for that. And this is because it's a small isolated site, which means that we can closely monitor any released Sihek, and also closely monitor the ecosystem to see if there's any impacts of those releases. And also because it's isolated, we don't have to be as concerned about Sihek dispersing away after the releases. However, those potential release sites outside of Guam are all outside the Sihek's native range, so they're then assisted colonizations. And assisted colonizations come with the potential risk of ecosystem impacts. So that's something we're potentially quite concerned about. So we're using approaches borrowed from invasive species biology to assess those impacts. And we're doing that by thinking about the potential mechanisms of impact the Sihek could have. So one potential mechanism of impact is through transmission of disease-causing pathogens to native species at those release sites. Sihek could also have impacts on the native ecosystem by predating individuals, predating native species at the release sites. They could also potentially impact the native ecosystem by competing with native species that maybe use similar resources to the Sihek. So if we first think about ecosystem impacts through disease, this is because we'd be translocating Sihek from the population on the US mainland across to islands in the Pacific, and that would mean that we would then be crossing ecological and geographical barriers. So we could then, with those releases of Sihek, we could potentially also be translocating these disease-causing pathogens. So to identify disease hazards and to come up with potential mitigation strategies, we're using disease risk analysis. And this work is being carried out by Dr. Claudia Carraro, who's also giving a talk in this session. So for more information about that work, please watch her talk. Other potential mechanisms of impact are through predation on or competition with native species at those release sites. So to assess impacts through these mechanisms, we're using ecosystem modelling. So this shows an interaction network where these orange boxes are different ecosystem elements or groups of species which are acting in a similar way in the ecosystem. And we can build this interaction network by creating those links between these species groups to show predator-prey relationships or competitive relationships or beneficial relationships. And then when we then add a Sihek into that system, we can use ecosystem modelling to see how these different species groups change in abundance after the addition of the Sihek. So what's next for Sihek recovery? Our next work, we're hoping to investigate other factors that could be constraining the ex situ population size and viability. So we're hoping to work with population managers to look at factors that may be affecting hatching success, as well as review and investigate causes of mortality and how those causes of mortality may be differing between the male and female Sihek. And we're hoping that we can then use that to inform management strategies to try and increase Sihek population size. We're also hoping to continue to work with all our stakeholder groups to decide our final release strategy. And potentially our first wild releases could be as early as 2022. So that's pretty exciting. Also, if you're interested to continue to follow Sihek work, then please follow our Sihek newsletter, which is available at the link there. And lastly, I'd just like to say thank you to all the rest of the Sihek recovery team, as well as our wider recovery group. And also thank you to you all for listening. Thanks.